All right, hi everyone. Welcome to another edition of our Subseasonal Forecast Contest. Today we're doing it on Friday, 9:30, so we have our special Friday edition. And we have a special guest here this week, Nat Johson from GFDL. And we're going to bring in Nat into the discussion here shortly. Nat has a long background in subseasonal research, so I think it's going to be a real benefit to hear from Nat on some of these topics. In terms of today's agenda, what I propose is we'll start with our usual attribution, look back at the past week and the past few weeks, the cooling season in general. We'll shift into the forecast. And then we also plan to spend or take about 15 minutes or so near the end for one of our student forecasters, Zach Magis, to talk about some of his MGO research. And again, we thought Nat would be a perfect guest to have for Zach to present share his research and solicit feedback. Beyond that, any other agenda items that folks want to cover today? Anything new or interesting? No? All right. Well, if you think of something, just jump in. I did just quick housekeeping. I know there's some feedback ideas for improvements to the HDD, CDD little tool we have here, and we did add some of that. I think there was an ask for adding the lag relationship, so you can kind of do that now. Just toggle back and forth. So we can look at this a little bit later, but that should work for you now. And I think everyone knows you can find that tool under research, under the research tab. It's the first item there. So, all right. So let's look at attribution. Let's look at how great we all performed over the past week. All right. So I'm going to go back here. And what was the last week? Was it the 28th? Yeah, I think this is it. Okay, so I'm going to sort this out. And I guess another quick housekeeping. This is the first, and if anyone can't see my screen, let me know. But this is the first week where we actually have the persistence forecast as part of the weekly table. So we actually have the verification. And again, these have been in research mode for a while. I think the data is correct, but if anyone sees anything that looks out of the ordinary or suspicious, please let me know. And of course, the first week that we add these, very basic persistence inputs, one of them scores the best in the table. So the 5-day persistence, that's, looking at, it's basically what it sounds like. It's applying, whatever that sort of anomaly, standardized anomaly from the last 5 days and applying it to the 1628 forecast. Well, that performed the best of all the human and non-human forecast here at the top, according to our CRPS, so 5-day persistence. But in general, let's see, the verification came in at 63.8. Just to benchmark that, this list is kind of getting long here. We have to figure out ways to filter this. But the 10-year is 55.6. The 30-year is 52. So after a couple weeks where we saw a little bit of a cool down, if you will, maybe that was it was definitely 2 weeks, might have been 3 weeks. Definitely verifications came storming back upward, the 63.8, and we can look at it here. I think I pulled it up. Yeah, let me just make sure this is right. Shift over to CDDs, HDDs. So, what am I doing wrong here? I was just going to pull up so we can see how it compares. What am I doing wrong here? August 12th, August 16th, right? Let's do this one more time. Maybe I don't know. Maybe I hit something wrong. Can't be 8 HDDs, and that's way too low. So we'll go August 12th, August 16th. If anyone sees me doing anything wrong, just yell at me. And we'll switch over to CDDs. Oh, there we go. I don't know what happened, but anyway, 63.8, that's what we said, right? And you can see this was the fourth warmest on record. So again, we came storming back here. Summer, made a violent return here with some pretty warm temperatures. In terms of the best performers, we already talked about persistence, but Matt Rogers again. Matt Rogers, that got to give him a shout here. He's had a good summer at CWG. He was near the top, or at the top in terms of human forecasters. ECMWF did well. Michael, who's on the line, also did quite well here. Near the bottom, this has been a recurring theme. I guess it's easy to beat up on the CFS, but the CFS had one of the worst forecasts other than long-term persistence at 49.3. So overall, most folks did quite a bit better than the 30-year and the 10-year, and with the exception, again, of the CFS. And if we want to just take a quick look at the summer so far, so I'll click on cooling season 2020, and I'll sort it. You can see that in terms of forecasts who have issued, well, it looks like consensus is the best in terms of forecasts that have been issued for the entire period 13 forecast. Industry number one, that's Maxar. So Maxar's done quite well here. And overall, it looks like most folks have done pretty well compared to the 30-year. Looking at directionally correct, I don't think anyone's 100%, but Paul Roundy is the closest at 92% for the 13 forecast. So Paul's only missed one forecast so far. We can look at bias real quick. There's definitely some bias to look at here. I was just saying, I guess the one that really stands out is the CFS, and that's that can be helpful, right? Because if this is a systematic bias, then bias correction might be able to help. That -10 definitely stands out from a research standpoint as something that might be useful, right? correcting that. Let me just take a breath here. We've looked at the weekly, we've looked at the summer so far, we've looked at the map, and I'll pull up the map here. And then actually, before I do that, before I open it up, let me just also open it up or share. This is Maxar's report from July 28th, verifying for this period, so August 12th to August 16th. So that's the Maxar forecast up in the top left. The EC is here where my cursor is. The CFS is over here. And let's just go over again, take another look at the verification from a pattern perspective. So from a pattern perspective, we had a lot of heat in the Southwest. Of course, everyone's heard it's been a national story, some of the heat in the Southwest. A lot of heat in the Northeast, and a little bit of a cool stripe, if you will, or a weakness is probably better. A weakness from the Northwest or Northern Rockies down into parts of the middle part of the country. So again, let's flip back one more time, look at how that compared. Yeah, maybe I don't know. I guess you could argue that the EC kind of had that, other than the Northern Rockies. It had the heat in the Northeast, had the heat in the Southwest. Northern Rockies was wrong, but it did have this little weakness in the middle part of the country. Of course, the CFS was kind of cold everywhere, but arguably it had the pattern right in the sense that the weakness was across the middle part of the country. So if you're playing the pattern game, maybe from a pattern perspective, both models maybe kind of had a hint at what was going on, but the EC was better calibrated. All right. Anyway, let me just open it up. What do other folks think about this forecast and verification?
I'd say even though most people did well, I think at least for me, it was kind of surprising to see the pattern the way it evolved, because there hasn't been a lot of heat in the Southwest. At least I don't think there has been up until recently. So I don't know if we've had this, if this is the same summer pattern that we've been having that's giving us all this heat, all these CDDs. I think it's a slightly different pattern, which to me is a bit, I guess, of a surprise. I'll call it, because I know there was at least one verification I saw where the Southwest was actually quite cool compared to compared to average, but now they're 130 degrees. So that's my 2 cents.
I was just going to pull up. You mentioned the Southwest. This is a pretty good site to show temperatures. This is Phoenix here. So Phoenix, this last event, if everyone can see my screen, 100, 115, 118. But they did, yeah, I think they actually did have some heat earlier this summer. So you see these temperatures, and now this is going back into July. Some of these areas did have a pretty hot July, just looking at this. So this heat event definitely, I think, was the strongest and maybe the most robust and sort of spatially the largest. But there was a little, there was definitely some heat here, right, earlier this summer.
I'm not sure if it's for Phoenix, but I read that or saw that somewhere in that area, 115 was considered their average high temperature. So that 111 might have actually been below average
Yeah,
in some of those areas, which is kind of crazy when you think about it.
yeah.
But
These nighttime lows are phenomenal too. You can see like 90, 91 degrees. Imagine
Wow.
93 degrees. Look at that, 93, 94, 94 degrees. Well, I think Death Valley, one of the days was like 101. The nighttime low was crazy. Let me go back here.
not something I'd ever want to experience.
You know, I have to say too about this attribution. I don't think Dave Darkangelo is on the phone, but I remember him saying something about like a week or two ago. And I guess I'm putting my industry hat on here a little bit. We were talking about, is this an isle of cool in a sea of warmth, or is this something that is with the last couple of weeks when it cooled off a little bit? And it does seem like, in hindsight now, that it was more like an isle of cool in a sea of warmth. I just pulled up. Here's the EC Ensemble 15-day strip, so to speak. So it's the daily CDDs going out, 15 days. It's got they have a bunch of model runs, but the most recent full strip is the 0Z here, and then Maxar's forecast is all the way on the left, and it's color coded so that above normal days are in the yellows and reds, and you can see most of the next 15 days are still going to be above normal. And when you look at the summer as a whole, it looks like this is we're still on target, right? If we go, let's go back to June 1st here to see kind of what we're on target for. Like near the end of summer, and I think you'll find, yeah, we're on target for the third warmest summer. This target here, this 1,020. And I guess that's always that's important to be. Well, it's important for a couple of reasons. Obviously, but I think as a forecaster, we talked about how like it's sometimes, especially 16 to 20 days out, it's very hard to catch some of the synoptic noise, if you will. And is like someone like David Arcangelo in the business, he has to deal with the fact of, is what happened in the last couple of weeks, is that a more permanent change that's going to reflect all of August, or is it likely to be a temporary change? Now, in hindsight, it looks like it was. He was kind of right, or he was right, and the fact that it was more of a temporary change. And I bring it up because how you're going to respond, I think, differently. You may, even as a forecaster, if you feel really confident that it's synoptic noise, and you're going into a summer where you just feel like, hey, it's going to be a top 3 summer, you're probably going to forecast really strong warmth most of the time, knowing that, hey, there's going to be maybe 2 to 4 weeks within a 12 to 14 week period where you're going to be off. But for those other 8 to 10 weeks, you're going to nail it, or you're going to be close. And it's more important to try to be right those and show the intensity correct 80% of the time than it is try to, to get those edge cases right. So there's a little bit of a side topic, but I was just thinking about, we were talking about this a little bit, how the market deals with this kind of stuff. It's not easy. It's not trivial. But that was some insight that Dave Darkangelo gave us last time. Any other thoughts on this forecast, or even just the change back to a warmer forecast again?
Dave, how did your MGO tool on the forecast website do potentially predicting this?
Yeah, again, it's a little bit of Monday morning quarterback, right? But let's just look at it. So here's the realized MJO and MJO forecast, right, as from the EC ensemble. And so the forecast verification here. I'm sorry. The period of observation here is what, the 12th to the 16th. So during the 12th to the 16th, the MJO was transitioning from phase 6 to phase 8. All right, so let's keep that in mind. And now we're solidly in phases 8 and 1. All right, so we can look at this, I guess, from a couple perspectives. We can look at this more contemporaneously, and we can look at it from a 16 and 20. I guess look at it more contemporaneously. And again, it's a little bit tricky because we were transitioning, but let's do it. So, quote unquote contemporaneously, it's one. We'll start like 1 to 5 day period, not quite contemporaneous. We're somewhere between August 10th and August 20th. It shouldn't matter too much. We'll say August 10th. So it's interesting, right? Like if you knew for certain that the MJO was going to realize between phases 6 and 8, it would have been, and you were using this tool, it suggests a transit. Well, I guess it suggests a transition period, but you wouldn't know necessarily, am I more in the cold, phase 7, or am I more in the warm? If I had to err, again, I have the benefit of Monday morning quarterback, but I probably would have said this is a little bit more of a cool signal. Now it's, yeah. But it could also, again, suggest low confidence, or it could suggest low confidence because of the fact that, again, if you knew 100% that it was going to be zipping into phase 8, you might also say, uh-oh, this could be a quick transition to heat, right? You might think that. So what you might do with this is, if you were using this tool at the time, and I don't even think we really had this, but you might say, I better open up my confidence. I might my spread, because this could be, this could be problematic. Now, if you're looking at it more from 16 to 20 days out, then I guess, you go shift down, and, then you, I guess, looking at the time, let's see, let me go back to this. So at the time this forecast were issued, what was it? It was, what did we say, the 28th or so? It was around the 28th. Double check that. Yeah, it was 28th, right? So, it's on the 28th. You're in phase 3. You're saying what happens 16 to 20 days later, right? That's how I think you might try to use it. I don't know. Again, it's easy to play devil's advocate. To me, I don't look at, there's something going on here at these phase 4, but then, I think that's, again, that's bias. Oh, hey, there was a heat signal here. I should go with that. I don't think it's super clear to me. You're in phase 3. It's kind of a weak, if you take it explicit, literally, there's a weak warm signal, but it's kind of messy. I think it's just kind of, I don't see like a lot of cohesion here, a clear, concise signal. So I don't see something that would have alerted me clearly to a strong punch warmer. That is what we realized in the last couple of days. Anyone else have any? Zach, anyone else have any thoughts on this?
Two things. First thing, is the mark date the date valid, or is it the day that we start the lag?
Yeah. So mark date is like forecast is the initialized date. So it is. So oh, you're saying, is it? Are we looking? Is the August 10th represent the target date of the forecast or the initialized date?
Yeah.
You're right. Actually, no, you're right. It is initialized. So technically, I should take this back to August 1st, because what did we say? It was July 28th or something like that.
Yeah.
So since it was July 28th, and this is mark date is basically initialized date, you should look at July 28th. So that's a good point. So you should be looking at this one. Conclusion might be about the same, but yeah, that's right, Phil.
Okay. And then the other thing is, I think what's interesting is that when I remember on Tuesday I was looking at the HDD plots for Maxar to see what the target was going to be for this period and possibly the next few periods. And what I thought interesting was previously the Maxar numbers seem to suggest that the next few periods would be closer to normal, but it looks like when we were looking at it just now that the next period is still going to be warm. So it looks like there's some volatility going on that isn't only limited to this past verification.
Interesting. Yeah.
And I remember specifically because I was looking at it on Tuesday and I was thinking to myself, I think after this period, the next period, I was going to have a near perfect forecast. Looking at this, not anymore.
And was the volatility? Did it shift colder or hotter? It shifted hotter.
It shifted hotter. Yeah.
Yeah. Yeah. Okay. Yeah. And I'm trying to see. Since the question about the MGO came up, let's just look back at their reasoning here. Did they say anything about how the MGO? They talk about the pattern likely positive VPO historically correlates with above normal temperatures in the north and west. I'm not sure that worked out that well. The northern Rockies was actually a cool area, but guidance from the EC is favored. Uncertainty from a low amplitude MGO has confidence. Okay, that's interesting. One of the ways they interpreted the MGO was, well, one of the ways they applied it, or how they applied it, was that idea about lower confidence. I just want to go back again real quick. It definitely, one of the things, not that we need to spend a lot of time on this, but I definitely encourage folks who are interested in this, take a look at this maybe offline. You definitely, you appear to see, I want to be careful with my words, a more cohesive relationship in the shorter signals. By 16 to 20, at least with the CDDs, there seems to be more noise. It seems like you kind of see that peak signal, somewhere, I haven't looked at it enough to say, but somewhere in the first 10 or 15 days, maybe in the 1 to 5. And that may be a little bit different with the HDDs. Definitely encourage folks to take a look at that. I think the HDD signal actually may be more kind of cohesive and, it may kind of hold together better into the longer range. And, of course, that may say something about the seasonality of things that, maybe MGO and maybe some of these other teleconnections patterns, there's sort of a longer signal further out than there in the winter than there is in the summer. Okay. Any other thoughts about the recent forecasts before we switch over and talk about the current forecast and kind of what Philip was talking about? All right. So the most recent forecast here was the 18th. So let's pull that up. All right. And just a real quick recap, our distribution, you can see on the board, we've got forecasts ranging from, well, some of these persistence metrics, which as we looked at, we looked earlier, this summer has been an extremely hot summer. And that's why these longer term, I think, persistence metrics are so hot. But anyway, persistence metrics leading the way at the top. And then at the bottom, we've got the 30-year normal. So with Nat, so I see Nat Johson, Nat's got one of the warmer forecasts here. Nat, this might be a good opportunity to kind of turn it over to you and just whatever thoughts you have related to your forecast, but in general, any other thoughts you have in terms of, in particular the MJO or any other subseasonal signals that you think are potentially relevant, useful, worth talking about from your experience? I think we'd all love to hear about it. And would you like the screen at this point, or?
Sure. Yeah, I got about like 10 slides. I can show kind of my thinking. Okay. Do you see my slides?
Yes.
Okay. So yeah. So I for my forecast, so I'll give the short summary. My forecast is 100% based on our best forecast tool, the CFS. So, okay, I'm kind of half kidding. My forecast actually was based on the CFS, but I don't believe it's the best forecast tool. But I thought I'd just try something a little bit different this week. So, a lot of my research has been focused on the cool season, the cold season. So, a lot less on the warm season. So I feel like maybe I don't have that many piercing insights on, on how to balance some of these warm season signals. So I decided I was going to try just to have kind of more of a data-driven approach to this week's forecast. And I don't recommend this as a long-term strategy. Just something to hopefully maybe something interesting along the way. So okay, so first of all, I have to catch up because I had not participated until now. So I want to get a sense of where we've been. So I just calculate the time series of the CDD anomalies this year, and also look back to last year. So this is the anomaly relative to the 30-year climatology, 30-year normal. And okay, so probably features that you're all familiar with. So I guess a number of things stand out. So first of all, as I'm sure all of you are aware, one thing that stands out is that it's really hard to go below the 30-year normal for CDDs. It's only happened a handful of times, and usually not by much. So that long-term warming signal is really stands out in the warm season. The other thing that I was kind of interested in is trying to understand how persistent are the anomalies. So so how much can knowledge of the short-term forecast inform the days 16 to 20? So so I calculate like the lag 1 autocorrelation. So this is the 1 week autocorrelation, and it's actually quite small, 0.23. So what that tells me is that, say I'm really confident in what the days 9 to 13 is going to be, either really warm or really cold. How much can I use that information to extrapolate to days 16 and 20? And at least on average, it seems like not much. So so I thought that's one thing that was maybe this is known to others, but it's just useful for me to understand a little bit more quantitative way. If you look at the lag 2 autocorrelation, even lower. So almost no relationship. So that means if you're very confident in what's going to happen in days 2 to 7, there's basically no statistical relationship with what happens in days 16 to 20. But keep in mind, this is correlation, so this is relative to the seasonal mean. So if there's this like a seasonal mean warm signal, then that may be persisting, but in terms of the variability on top of that. Okay, so that was just understanding a little bit of the recent history and just help me understand a little bit more about how well some of these signals are persisting from week to week. And take home was kind of not that much. Then I looked at, over these 2 summers, what is the mean absolute error for the main forecast tools. So I'm looking at this in a bit of a deterministic sense by looking at mean absolute error, but I thought that's still, even though we're making probabilistic forecasts, this can still give us an idea of what's doing well. So this is the MAE of the 30-year normal so this is kind of the baseline, so around 8. EC is a little bit better. CFS is a bit worse, as we've seen. Interestingly, the MJO analog from MAE perspective has been comparable to EC over these 2 summers. Trend has been even better. 10-year normal has been the best, and consensus is a little bit worse than trend. So does this look reasonable based on your experience?
You forgot to add my forecast, which would have been a little bit higher than the top of the chart. No, it does actually. It does, at least in my opinion. Anyone else?
I may have missed this, but are these your data sets? Like, do you have your own MJO analog? Or are you taking the data from the contest and analyzing it in this way?
This is all from the contest.
Okay.
So, yeah.
So the anomalies are the population weighted anomalies, just like the contest.
Yeah. So,
okay.
I mean, it's possible I could have made an error somewhere, but I try to be careful. So yeah, this is all from the contest.
Got it.
Okay. So then I want to look at a little bit more at the at both the trend and MJO forecasts. So these are the time series. So so you can see, yeah, the trend is noisier than the 10-year normal, smoother. And I tried to look at what kind, just doing some very simple combinations with the trend and the MJO signals. So again, this is MJO alone, trend alone, 10-year normal alone. Then I thought, what if we add the MJO and the trend signal? So the motivation here is that you think that the MJO and the trend, they really may be largely orthogonal signals. So if we can add the signals together, perhaps that's better than just considering one or the other. And of course, when you do this, you have to add the anomalies, not the total. But adding the MJO and the trend doesn't help. Interestingly, you add the MJO and the 10-year norm signals, and it looks like it's slightly better than either the 10-year normal or the MJO. So, but it's obviously very close to the 10-year normal. So not enough data to draw any conclusions, but it's possible that if you combine the 10-year and the MJO, maybe that's better than considering either the MJO or the 10-year normal alone. And then there's also just weighting, 50% each, and that doesn't seem to really help. So from here, still 10-year normal is pretty good, and possibly combining the two signals might be even better. Okay, then looked at the dynamical model guidance. So EC and CFS, and of course you see in the raw form CFS has been pretty terrible. Obviously, very strong cold bias. But one thing that struck me is that if you take out the bias, you look at 2020, you can see CFS is actually looks like it hasn't gotten the variability fairly well. It just has that really strong bias. And if you look at the bias for the 2 years, so here I'm showing the EC and the CFS bias. So the first bar is the full 2 seasons, then 2019 and 2020. So of course you see EC has much less bias, as we all know, but a little bit more variable bias between 2019 and 2020, where CFS is consistently quite cold overall. I mean, yeah, but consistent. And then so I try to ask this question. So what if we took the forecast of the model and we just subtracted out the 2019 bias? And I thought, okay, that's fair in the sense that any one of us could have known that information prior to the start of this CDD season. So it's something that could have been applied to the forecast. And this is what we get. So for the EC in green, it doesn't really help. But for the CFS, after doing the bias corrections, actually does pretty well, maybe surprisingly well. So if we look at the MAE now, so this is showing the again 30-year norm, EC, CFS, MJO trend, 10 years, same thing, consensus. Now I added the bias corrected EC, and this doesn't help, it actually does worse. But the bias corrected CFS actually is looking the best among all these signals. Then I just did some experiment. What if we just combine them with some things? So this would be, again, this is the 30-year normal. This is the MAE for what I showed earlier, the bias corrected CFS. You do half and half, equal weighting, CFS to EC, doesn't help. Equal weighting to the, with the MJO or the trend or the 10-year, doesn't really help. Although in hindsight, I might still consider, it's not much worse. Not certainly not significantly worse. And given that this 10-year normal has been, I think, more of a reliable signal long term, maybe it would be smart to give some weight to the 10-year normal. Another clue I look at is to consider whether or not the variance of the model forecast look reasonable, because there shouldn't be too much variance in the dynamical model forecast, because even if we had a perfect model, we're not going to get all this signal in the days 16 to 20 because of just the chaos of weather, the butterfly effect. So the ensemble mean variance should be substantially lower than the actual variance. And just eyeballing it, it looks like the EC has too much variance, and the CFS is not immediately clear. It certainly has less variance than observations, but maybe it's might be a little bit too much still. So one way that might be a little damp that signal would be to add some weight to the 10-year normal. But for my forecast, I just said, okay, the CFS had a hot streak this year if you apply bias correction. So that's what I just took. The CFS subtracted out the 2019 bias, and that was my forecast. So I do not, and I'll tell you, I do not think this is a good long-term strategy, and perhaps I'll get burned even in this forecast. Ideally, I'd be able to, working with a lot more data and have a lot more testing these ideas, because this could very well be very fluky. I mean, but I thought, it's interesting, and I might as well just see if I can, I'm gonna throw a coin in the CFS slot machine, see if it works. So that's basically my thinking. Any questions?
Yeah, I think that's awesome. I mean, anybody on the call right now can attest to this. We've been talking for months now how it appeared that the CFS's bias was consistent. It was doing poorly CRPS-wise, but it seemed consistent. This is the first time any of us have actually gone and done a bias corrected CFS. And based on what you've shown right here, it looks maybe just in 2020, it looks like it might actually be a successful metric. So that's something to keep in mind for any of us down the line. But I think that's great. Glad you did that. We've been talking about it for a while now.
Yeah, I think it's at a stage where it's keep in mind. Certainly not solidly true, but yeah.
Right. The sample size here is maybe 13, 14 forecasts. So
Yeah,
it'd be, I guess, ideal to go back and, we do these contests once a week, but if you went back and did this kind of analysis for every day, although, not every forecast is independent then, but, or you look at multiple years than just two to get more samples.
Absolutely. So yeah, if I were to do this for, my job or for, scientific research, I would definitely need a lot more data to test on. But I'll do what I can with work with what I have, and
Mm-hmm.
at least it's a hypothesis basically at this point.
One other comment that isn't directly related to the CFS, but more so one of your earlier slides, you were showing the correlation, the autocorrelation between, I think, the 1 week lag and the 2 week lag. Yeah. So just thinking about this, I guess this doesn't lend too much promise into the thing we were thinking of, where we were going to take the sort of like a dynamical persistence of, say, what the EC was forecasting in the 6 to 10 or 11 to 15 day period, and use that to try to forecast the 16 to 20.
Yeah, it would. That's so that's what one thing I wanted to. That's why I wanted to do this calculation. I'd say if there is a seasonal signal, I mean, so correlation is relative to the seasonal mean. So draw a line to the seasonal mean, and so that might still be captured, but the wiggles on top of it just doesn't seem like there's too much persistence with those subseasonal wiggles.
Right. Yeah, I agree. This is really interesting. Maybe we can talk a little bit offline. I know our group here has been, for a while, we've been looking at trying to add like a bias corrected input, just, like, even if just for reference, right? Exactly what you're doing. So I think maybe this is the step that we needed. because to Dr. Decker's point, we do have, and actually Zach's going to talk about this in a second. We do have, thanks to Maxar, we have about I think like 7 years of data, of CFS data available. So we could extend this study and see how the results stack up. So that could be interesting too. And this, I know just for the sake of time, this might be a good segue. Nat, is there anything else in terms of this research that you want to share?
No, that's it.
So if you don't mind, let's segue to Zach's research, which is also MJO related, because I know Zach really wanted to share some of this with you, Nat, and kind of solicit your thoughts. And again, it does fall into this realm of looking at how sort of the MJO or the models perform as a function of the MJO. So with that, I know, Zach, we don't have too much time, but hopefully we have enough time here where you can hit some of the takeaways and get Nat's feedback here.
All right, can everybody see my screen?
Yes.
Yep.
All right. Hi, everybody. For a while now, I've been working with Dave using some data from XR and from the forecast contests in general to try and discover potential relationships between model biases and the MGO. So the purpose was to establish a relationship between forecast guidance and MGO phase to discover how well the models, particularly the EC and the CFS, resolve the phases and if systematic errors exist. I had done a little bit of background research, and these two studies in particular I found kind of lended themselves to my study. The first one, Matsuda and Endo from 2011, found relationships between how well the EC and the GFS performed progressing and initializing the MGO. The EC did better with phases 1 and 4. The GFS did better with phases 5 through 8. And this second study by Barrett in 2018 found in the winter of 2018 in the eastern US that warmer temperatures occurred when the MGO was over the Indian Ocean in the eastern US, and colder temperatures occurred in the eastern US when the MGO was over the Western Pacific. So my study kind of fits in, and so one of these studies found that the models resolve certain phases better, and then the second study found that certain phases lead to certain temperature anomalies. So I'm kind of molding those two together and seeing how well the models predict temperatures based on the MGO. So thanks to Maxar, I have 1 to 30 day gas weighted HCD and population weighted CDD data from both the EC and the CFS. And I also have the verified data that we use in the contest. The dates that we were given were from 2013 to 2019. The data sets aren't perfect, but it was still plenty of data. So my methods, to stay most relevant to the forecast contest, I looked at the sum of the 16 to 20 day model values and verification values. I did a little bit of bias work, and the bias I used was that I used the model 16 to 20 day value minus the verified 16 to 20 day value. And the other main point was that I was using initialized MGO phase, so that when the MGO was initializing, I'll say phase 1, I looked at the model forecast and verification 16 to 20 days later. And that's what I did my main analysis on, was these types of values. So let's start with EC. I looked at just all the data, kind of see just these broad, if there are any broad general patterns. So these are these biases. So anything above the 0 axis is a cold bias, anything below is a warm bias, and this is just for all the gas weighted HGD values, as you can see up in the top left. So we can see the EC, it's kind of all over the place. It's 4 of the phases have a warm bias, 4 of them have a cold bias. That's certainly interesting. And then here.
Sorry, I'm just thinking this would seem to be kind of consistent with what you said before. So phase 8, that would be, you tend to get a negative NAO. cooler over the east. So if it does worse in these phases, then it may not be getting the cooling over the eastern U.S. And that's why there'd be a warm bias. Does that sound reasonable?
Yeah, it does. So these are just these bias values that I calculated. Here are like the mean absolute errors of those same data. We can see it's a little bit different. The story is a little bit different, especially for like that phase 8. The phase 8 value sticks out the most as having a significant warm bias, but if you look at the mean absolute errors compared to some of these other phases like phases 3, 4, and 7, the size of the errors aren't actually that bad. So, there's a lot to take in here. I'm going to go quickly, but I can certainly share these slides with everybody if they want to see further. Here's all the CDD data for the EC. We can see it's pretty much a cold bias across the board. And similarly, the mean absolute errors are smaller than they were for the HDD data, and they're actually kind of more consistent, which is, they're almost, the warm biases are consistent there as well. So there's a lot of interesting things going on there. So my takeaways from that data was that the EC has a consistent cold bias in the CD data, but it's biased in the HDD data. It's all over the place. That phase 8 looked interesting, and that the errors in the mean absolute errors in the HDD data are larger overall than the CDD data. This is where this gets really interesting in terms of relevancy to the forecast contest. So I separated all this down into the degree day season. So, as we know that when we're forecasting HDDs, those May through September months don't really accumulate anything. So you want to filter those out because it's going to influence the data. Vice versa for the cooling season, we filter out those winter months. So here we have the mean absolute errors during the heating seasons. And the heating season I define as October through April, when HDDs accumulate the most. So these are the mean absolute errors for October, November, December 2013, and then January, February, March, April for 2014. Here they are across the board. And then similarly for the cooling season, obviously the years, it's not a staggered, we're not going from year to year because all those months are contained in the same year. So my takeaways from that is that during the heating season, each heating season has like 1 to 2 phases that have larger errors than the others that kind of stick out. So like in 2013, 2014, phase 4 and phase 8 have pretty large errors compared to everything else. Phase 7 in 2014 and 2015, phases 3 and 7, and so on. And then the other point I made was that it seemed that the EC did pretty well for phase 7s in 2018. That's the smallest mean absolute error on the entire table. So that's certainly a data point that I could investigate further if I wanted to. And then we switch back to the CFS. Let's take a look at all the data for the CFS. Kind of what we expected. This is the gas weight HDD data. Just cold bias across the board. And then similarly, here's mean absolute errors for those same data. We can see that phases 3, 4, and 7 seem to have the largest errors. The biases for 3, 4, and 7 are across the board pretty large compared to the other phases as well. Then we look at the CDD data. Also not a surprise, we see this cold bias across the board. And then mean absolute errors are not as big, but we do have this phase 1 that kind of sticks out as being larger than the others, and the bias in phase 1 is larger than the others as well. So lots of interesting data points to kind of sift through. Takeaways, the CFS has strong biases in both the CDD and HDD data. And then it's kind of similar takeaways as before, that the errors in the HDD data are larger overall than the CDD data. I did the same thing, separated by degree day, season. Here we have the heating seasons, October through April. The most interesting thing I found was that in 2016 and 2017, phases 1, 2, 3, and 4 have large errors. And then it kind of, they're not as large through phases 5, 6, 7, and 8. But then if you keep that into account and you're starting to forecast in the next year, you're thinking, okay, those first 4 phases, pretty volatile. So that's something to keep in mind. But then if you look at 2017 and 2018, the error is almost cut in half. And then if you look at the 5 through 8, those are actually the large and have overall the larger errors. So there's a lot of volatility, and there doesn't seem to be a consistent year to year, especially in this 2 heating seasons. So that was something I found that was pretty interesting. And then here's for the cooling seasons, main takeaways. It seems for the most part that phases 1 and 2 are the most volatile. I mean, there's some big individual errors, but overall, phases 1 and 2 consistently have the largest errors.
Why are you getting not a number for it? There's just never was in phase 7 that cooling season, or?
Yeah, so this is for the CFS. The data I was given started in late August, so I only had like the end of.
There's a few. Okay,
August.
just a few.
So
Yep.
there's just no phases 7 or 8.
Okay.
Late August. Yeah, there's some the data having some missing data certainly gave me some issues, but I still wanted to show you what I had found anyway.
Mm-hmm.
So take 2013 a little bit with a grain of salt. There's not a lot of data compared to the other phases. So I just went over those takeaways. So here are the limitations. As I had said already, the data set's not very large, and even what I do have is incomplete. Certain years where I'm missing some data. The CFS I have model runs from every day, where the EC I only have it for twice a week. Obviously, we want to expand. Maybe there's only 7 years here, maybe 10 to 15 years. And the study doesn't factor in all the other variables that could be influencing what we're seeing. The other teleconnections, El Nino, soil moisture, sea ice. It's not a perfect study. But this certainly does lend itself to some future research ideas. Dave and I had talked about an amplitude filters. We wanted to see what the effects of only those high amplitude MGO events are, see if the errors are larger or smaller. Talked about creating phase diagrams like the ones that we've been using on the contest, except from a model perspective, and then even combining the effects of the other teleconnections with the MGO, potentially finding like a cross correlation between the MGO and the NAO, something along those lines. So that's kind of what I had done so far. I don't know how much time we have, probably not a lot, but yeah, if you guys have any questions, you're free to ask me now. I can send this to any of you if you want to look at it further. I know I went through it kind of quickly, but thank you for listening.
Yeah, thank you, Zach. That's very interesting. Yeah, a lot of neat stuff. I think I take time to digest all of it. Yeah, one thing I'd be interested in. So you have those MAE charts by year. It would be interesting. Have you done similar charts for bias? Because if you see that there's consistent bias in certain phases, and if these biases are different, there's differential bias by phase or maybe groups of phases, then that, if you see that consistency year by year, then that tells you have potential to exploit that MGO dependent bias to correct forecast. So I'd be interested in seeing like how consistent some of these biases are year by year, and maybe individual phases it's very noisy, but maybe if you group phases 1 and 2 or 1 through 4, or maybe there's a more robust year to year signal there. So that's just one thing that popped in my mind.
Yeah, I was certainly trying to factor that in. What I just discovered was that looking at the directionality of the biases, I didn't think my method was doing the best. Lynn had suggested looking at the positive and negative data at the same time and not averaging it all together. That would kind of filter out some of the noise. But I think the first series of charts where you could look at the bias at the same time as the mean absolute error gave you a better story. And there's more to take in there. So I'll certainly keep that in mind.
Sure. And just to add to that, something I thought of is, I know I mentioned this point a lot, but one thing I like to look at also is variance, just so that also gives me a better idea of whether something is consistent or not. So like, for example, if we look at phase 1 from year to year, the variance is or maybe not phase one, but let's just pick one of the phases. For example, the variance year to year might be very high, and that might suggest that the signal is not that consistent year to year, but maybe within the year, maybe the variance is much lower, suggesting that at least during the course of the year, you might have a more consistent bias that you could factor.
No, that's a great point, Philip. Thank you.
Do you have any plans to submit this for the AMS meeting?
I hadn't thought about it. I don't know. I guess I didn't even think that it was AMS ready, but I don't know, maybe.
Well, AMS is in January, so you have some months to make it AMS ready.
Okay. All right. Yeah, I'll certainly keep that in mind. We can talk offline with Dave about it.
24th. So you have 3 days.
Yeah.
Yeah, there's one.
Well, I got an email today. They extended a lot of the deadlines to the 31st.
Oh, there you go. All right.
I often submit abstracts on results I expect to get, and then I wind up stressing out a month before the meeting when I don't have those results. But, but it's an option.
That's a good point. All right, well, I know we're a little bit over, but this, thank you. Thanks, Nat, for sharing. Really interesting is potentially these new bias correction methods. Again, I hope, if you don't mind, maybe reach out to you offline and get a little bit more information on your methodology, and then maybe that is something we can integrate in the not too distant future into our forecast contest. And then with Zach, I think there's some good follow-up ideas, and Nat, hopefully we could continue to keep you in the loop on Zach's research, and occasionally solicit feedback from you on ideas. And I definitely think, in particular, like you said, with the phase 8 and potentially that physical relationship with the NAO is certainly something we want to look at. So we'll definitely do that.
Great.
All right, well, thanks again for everyone for a great meeting. And I think, Zach, next week we're going to return to our usual Tuesday schedule. Is that right?
Yes.
All right, great. Well, everyone have a good weekend. Thank you.
Thanks, you too.
Yeah, thank
You
you.
too.
Bye,
you.
guys.
Bye.
Bye.